Hi guys, welcome. This is the second video on project crashing. In the first video, we talk about project crashing, shortening project duration using a manual approach. And this time I'm going to use a linear programming approach and optimize the project crashing for a certain project. To do that, you need to have your project network diagram handy. You also need to have your activities, predecessors, their durations. You need to have the cost to crash each activity and maximum crash days, and also some information about the indirect costs and the savings per day from those indirect costs. And all the information, if you want to watch the first video, that would be great to kind of get the idea. And now we will just do the same thing using Excel. So in this template, what I have is I have from my network diagram, I put every possible path, which is an arrow between each node, each task, between tasks in my project network. And I also added two more nodes in here, and those are the start and end node. The reason for that is sometimes for certain projects, the ending node may not be a single node. It may be needed to have to finish that with a merge activity and just consider another node with zero duration, and that would be our end node. And we could do the same thing for the beginning, and we could just put a start node with zero duration. It could be maybe the first one could be a kickoff meeting and with a zero duration, and the last one could be your celebration with no duration. So it kind of helps you to build your model. So every path, every arrow from between these nodes are put here, start to A to B, A to C, A to D, as you see here. And let me just also put that start here if you want to kind of consider that. Start to A to B, and then there is also a finish node, okay? So the idea is very simple. The idea is that whenever you have two activities here, what you are proposing is the minimum duration between the start times of two activities that follow each other is going to be the duration of the earlier activity. What do I mean by that? The idea is that, let's say A takes 3 days and B takes 6 days. And let's say A starts at day 1 and B needs to start 3 days after A started, because A needs to be completed in 3 days and B can only start when A is completed. So if I consider like very basic math here, if I say that the start day of A is considered to be XA and start day of B is considered as XB, so the XB minus XA should be at least the duration of A. Okay, so in this case, the start B cannot start before A is completed, and A is going to be completed in the duration of A. And each one of these has a coefficient, like this one is 1 times XB minus 1 times XA, and then the duration here. So I'm going to be using those ones in my model. So let's just first look at those places and how are we going to enter those start times. Luckily, we are not going to do that ourselves. Excel is going to help us with the solver in there. And we are not also going to put the reduction amounts there. And we have the original durations, and then we have duration after reduction. So if I reduce it 1 day, I would be able to see that it reduces to 2 days. And I'm not going to put anything in there either. So these are my decision variables. Excel is going to populate those using an algorithm called simplex, and it is going to just give us the best optimal result. And these are the cost per day crashed and these are the maximum reduction amounts. So let's try to build that relationship in my model here. And what I need is I need to put a -1 here and 1 there. And I would have to then, if I multiply these with the start times, I would be getting this notation, 1 times xb minus 1 times xa, right? So that's for start and a, but a and b, it's going to be like this, -1 and 1. But if I want to kind of automate this, I could just put a simple if statement, and I can say if this is the start node, if this is equal to this, then I'll have to put a -1 there. Otherwise, I'll say if, and if this one, the next one is equal to the top value, then I'll put a 1. Otherwise, I'll put nothing, close it, close it. There are 2 if statements that is going to give me that -1 value. I also need to put my $signs in there to be able to copy this across and down. And if you don't know how to use the $signs, the absolute and relative referencing, you can refer to my other video, another video on that. So for B10, this, I want to copy this down, but not across. So I'm going to lock its column. Column B is going to stay in its place, but row 10 can move to 11, 12, etc. So the C10 is the same thing. And then D9 is going to be the opposite. I want that to move across, but not down. So I'm locking the number, which is the row value, okay? So if I do that, and maybe here, you can just check it if yours is correct, and you can copy this across, and then you can copy that down. And you see now that -1s and 1s are put. You could do this by entering them one by one, but this is just giving you an error free approach, and because the other way you may just put your -1 and 1s in incorrect places. And then the difference in start times is going to be, we're going to use a function called sum product, and we'll multiply these start times, and we'll put a $sign on their rows, comma, we'll just use these values. So what does the sum product do is that sum product multiplies them one by one and adds them. So -1 times this plus 1 times that, it will just do that. The others are 0, even though if there are some numbers there, they are not going to get affected by the duration is not going to get affected by that. So here 0 and 0. Let's say just put some numbers to kind of get an idea. If A starts at time is a 1 and then B starts at 4, and I would be able to see that 4 minus, then will be the 1 times 1 is there. So here the 4 times 1 minus 1 times -1 is 3. So B needs to start 3 days after A, and B cannot start at 2, for example. Why? Because we know that the A's duration is 3. So Excel is going to figure that out by itself in the algorithm. Now let's look at the durations, but for the durations, we will not use the durations that are listed at the top. We will use the durations after reductions to make that take into account the the crashing idea. So to do that, I'm going to highlight this whole table with the titles, and I'm going to call this my crash table, or just C table, okay, with no blanks, just one word. And I can now refer to by HLOOKUP, and if you don't know how to use HLOOKUP, then you may have to just review that. I'm going to try to find the value here, duration of the start, and in my table, so I'm going to look at start, and the table is C table, and I will look at the row index number. When I find start in that table, I will move to 3, 4, 5th column of that table, and I want an exact match. So the duration of start is 0, but the duration of the others are correctly entered there. Did you have to use an HLOOKUP function there? No, you did not. So what you could do is you could just directly make them equal to that. You can make this equal to this value, and then the next one is the same, but this kind of automates the idea again, also helps you learn the functions like HLOOKUP or if statements. So then let's look at the project duration. So the project duration is going to be the end day of the project. Okay, so that's my project duration. The project takes how long? The project takes now nothing because there are no durations popped up there. So I am all set. What I need to do is I need to go to data tab, and I'm going to first figure out how long does the project take. I'm going to find the project duration, and I need to go to my solver. If you do not have a solver shown in under the data tab, you go to file, if this is a PC, and file options and add-ins, and right in the middle go, and the solver add-in, and okay. If you have a MacBook, I think it's easier. You could just search for Mac Excel solver. It should just give you the solver option. So we click on the solver, and let's just reset everything here. And because you won't have anything, I'm just going to start with my settings. First thing I want to do is I want to set my objective to be my project duration. So I want to minimize my project duration, and I want to change my values, and my values are going to be these yellow cells, the start days, comma, I also want to find out the reduction amounts. Okay, and then I have my constraints. My constraints are going to be my duration, my reduction amounts cannot be more than the maximum reduction amounts. So this one is taken for every one of them and compares them against the other, and just make sure that you do not reduce more than these values there. And I also want to look at here, and I want this difference in start times to be at least as large as my project, the duration of that early activity. So then I click OK, and then I am all set. And what I need to do is I just need to run my model. What I'm trying to do is I'm trying to minimize what? I'm trying to minimize my project duration. So what I see here is that I realize that my project duration is 21, and it just did not take into account any cost value. So in that case, it is really just reducing all these activities and reducing the project duration without really, do we want to pay that much money to reduce the project? We just want to get to know what is going to happen to my the total crashing cost, and I don't want to pay an additional amount of money for this. So I want to look at my crash cost and minimize that instead, so that I won't have any problem with my project duration. I can control that. So let's do that, calculate my crash cost. So if I reduce these activities by this much, and then how much money they're going to cost me? This one is going to cost me $20. This is going to be 2 times 25. This is 1 times 30. So to find that out, I will just use a sum product function again. And that's going to be sum product of the reduction amounts times the cost per day crashed. And that is going to give me $170. So let's now try to minimize that crash cost instead of the project duration. So if I do that, I'm going to minimize the crash cost and just solve it. Now I realize that my project duration is 25 days. So that is my project duration initially that I could find that as 25 days. So this is after I have done all this crashing, but before the project duration was 25 days. So what if I don't want to finish this project in 25 days, but I want to finish this project in 24 days? So then I can put a deadline on the project. And to put a deadline means that I need to add that constraint, I need to put that restriction into my solver. So I'm going to go and add that. I'll tell that my project duration should be no more than the deadline. Okay. So what's going to happen now is that the solver is going to try to make this 25, but then realizes that it is not helping because there is another requirement, 24, then the solver will have to pay the crash cost, but it is going to choose the best option. So then if you do that, you realize that the crash cost is $20 and it crashed A. So instead of doing this manually, as we have done in the first video, we are able to get the crash by just using the solver. So if I reduce this to 23 and run the solver again, now this time it reduced what? It chose D as the second option to crash. And if I try this one more time and just use that line to be 22, and this is now going to be $75, it chose F as my third option. If I go to 21 and solver again, now it is $160 in total. It crashed the E and F and one more time D. Now I'm going to go to 20. Let's try 20 and solver. Now you need to guess this if you have watched the first video. Solver could not find a feasible solution because there is no way that we could reduce this project duration to 20. So the reason is that there is a path with no possible crashing. There is no way to reduce the project duration further than 21 if we have these maximum reduction amounts. If we don't have them, maybe we'll be able to do that, right? So I'm going to make this 21 again and solve it, and we are able to find that. But taking into account the not the deadline, but directly the indirect and the direct costs, can we directly find the project total cost and do that in that way? So for example, let's just change this back to 25 and solve it. And now we have no crash cost and our total cost is, let's just calculate that. So the cost is going to be, there's an initial direct cost, right? That is going to be our first cost. And that is just adding up all the cost values for the normal activities. So that $450. If I have additional crash costs, then I'm going to add that crash cost on top of that. That is going to be an increase in my cost. But then I also have an indirect cost, which is $400. But I have to subtract 25 minus, because the project original duration was 25, minus what the project duration here is, okay, B21, and that times 50. So what does this tell us? Let's say if the project duration is 24 days, 25 minus 24 is going to be 50, and one times, then we'll multiply that by 50. It is going to be a $50 decrease from the cost, from the indirect costs. If there are 2 days, then we'll have like $100, 3 days, $150, so on. So instead of reducing or just minimizing the crash cost, and what we could do is we could directly minimize the total cost. And minimizing the total cost is going to be that. We'll just change this to the total cost, minimize B29. Everything else is the same. Just click OK, and then we are now done. Directly, we are able to find 22. So we do not have to go ahead and try this one by one. We could just set it up in this way, and we are able to find our project, the optimal number of days to crash this project to in the presence of the indirect and the direct cost values. And that's it for this video. Thanks for watching.